Hello everyone and welcome to a new demonstration on GIS software. And in this demonstration what we are going to do, we are going to handle false color composite images. As you know that one of the major sources of data in GIS is coming from remote sensing, satellite based remote sensing mainly. So, we have to handle this also. This comes under the raster. As you know, raster having two types of raster. One is in grid form, and that is best example is digital elevation model, and then image form, and that is what the satellite images which we will be doing. So, here we will be handling false color composite images, how they are handled in on a GIS platform, and what basically meaning also of false color images, and then we will also discuss briefly about the image enhancement. So, before I directly go for demonstration on the software, let me first explain this about this false color composite, that is, or in short we say FCC. The reason here is that why it is called false, because for infrared channel we are assigning red color. Now, why this compulsion is, as you know that any colored image is made from three color components, which also we call primary colors and which follow the additive color scheme, and these three components are red, green and blue. Now, for blue part of EM spectrum and green part of EM spectrum, we are having satellite images. They can go as it is in this color composite, but we would like to have one more addition in our for another component, that is for red component, an infrared image, infrared band of a multispectral satellite image. Now, this infrared band, as you know that though it is called red, but we cannot see from our own eyes, though instruments can record in that part of EM spectrum. So, how to which color to assign to this infrared channel? So, then only left option for us is, because green and blue has already gone. So, now only option left for us is to assign red color. And when we assign this kind of combination, that infrared channel having red color and blue and green are and two bands of a multispectral remote sensing, then it is a false color, a composite color composite is made. But false color, why? Because the vegetation is having highest reflectance, a healthy vegetation is having very high reflectance in infrared channel. And since we are assigning red color to infrared channel, and therefore vegetation in false color composite will appear as red, and you know that vegetation is not red, vegetation should appear green, and therefore this is why we call as false color composite. Now, there can be a question, can't we generate a true color image? Yes, if we are having that kind of number of more bands, then a near true color image can be generated, but exactly the true in the real color image cannot be generated by these things, by the satellite images inputs. So, the problem is that we are assigning infrared channel red color, and therefore it is called false color composite. In a standard false color composite, that image will always have vegetation in red color. So, let us now start our demonstration. So, what we are going to do on this ArcGIS software, we will try to add one image here and then see what really happens to that image, and then we will see that how this is created. So, if I take an image here which like this like I am taking this Moscow spot image, and I add this image. So, once it is the image is added in our view, as you can see that though I was mentioning that vegetation should appear in red color, but here it is appearing in blue color, because the system is automatically assuming that the first channel is a, because this is color composite. So, definitely there are 3 bands which are being used to create this color composite. And so, here the system is assuming that the first channel is bearing the infrared band, whereas we know that it is not, and that is why it is appearing here blue. So, if we change this one to 3 and blue to 1, and when we apply this one, now it is a standard false color composite. So, whenever you display any image, you have to be little careful that which band is being assigned to which channel. The infrared band must be assigned red color, then only you can create a false color composite, otherwise it will not be possible to create a false color composite. Similarly, if I want to, this was the ready made sort of false color composite, but if I want to create false color composite, then what I have to do here, that I can take any data set, like here if I take this data set of list 3, and as you know that there are 4 bands are being displayed. If I bring all bands together and let us see what happens. So, also this part I have already discussed, by that is the creating parameters. So, it will display our make display faster. So, whenever first time any image or grid is or raster is displayed in the system, it will always ask for the to create a pyramid. So, I am going to accept that for all 4 bands, and as I was mentioning that these the bands, this color composite is made from 3 bands. Now, here what we are seeing all bands individually. So, this is band 5, but you are seeing this is band 2 and this is band 3 and this is band 4. Visually you may not find much difference, but they are definitely having different and differences in it. Now, in their pixel values. Now, what we have to what we will try to create false color composite using this one. So, again we can go for search and say that color composite, because we have to search that tool, and many times it is difficult to remember where it is. So, the best way is to just search that tool within the toolbox, and then you can just click and those things will come to us. Now, what we are going to do, we will add all those images which we wanted to have here. So, I am going to add all these images one by one in our to create a color composite, and we will add 4 channels, but at a time only 3 channels will be used. So, we can check that which one is giving the best result. So, likewise I will add the next one and then next. All 4 have been added, and now we have to provide where it will be stored. So, let me accept whatever it is location it is showing, and it might take some time to create a false color composite, because it has to combine all 4 bands and then you get a false color composite easily. Remember that the first band is band 5, then 2, then 3, then 4 likewise. So, we will be then once it is added, then we will be seeing how whether it is following the standard false color composite scheme or not. If not, we can change the assignment or we can assign different colors two different channels and the appropriate one, and can get a standard false color composite quite easily. Here this now it has been added this one. So, let me go here and check why it is not coming properly, because how I can say it is not coming properly, because the water body generally should appear as a black, very dark. Here it is appearing green. So, it seems that it has not correctly got the bands. So, what I will try? I will try this one and change to this one 432. Let me apply this one. Yeah. So, this is now band combination which is giving us quite good result. We can also add the remaining band here in this composite, but that may not bear any good results. So, this is how a false color composite can be generated quite easily with your input bands which you are having. So, again I will just recap this thing, that in order to create a false color composite, you need one standard false color composite, you need one infrared band, you need one blue band, and you need green band. So, blue and green will go two blue and green red channels, whereas the infrared one will go to red channel, as it has been done like this here. So, when we do like this, then we get a perfect or standard color composite, because why we are saying standard color, because once it is a standard color composite, then interpretation on a standard color composite can be done quite easily by many people, because the lot of interpretation keys are based on standard false color composite. So, then therefore, it is always good to create standard color composite rather than combining bands arbitrarily to different color channels. Now, this image which is being displayed, if I say now this is completely unstretched or no enhancements are there. As you can also see here that there are no enhancement. Let me shift this image little bit and then open again that one. So, both things can be seen clearly. Now, here you see that stretch type, because now we are discussing how to improve the quality of our image for our image interpretation or any further processing. So, currently it is no stretch. Now, there are various stretching or enhancement techniques which are available here, like here of course, the custom design, we can do our own custom stretching if we are having full knowledge of the distribution of images, pixels and frequency, then standard deviation, then histogram equalize, minimum maximum, this is also called linear stretch, and this is histogram will be being put in a nonlinear stretch, and then percentage clip, and some Esri has also made their own, and sigmoid also. So, there are various these stretching schemes are available for us, but before going for any stretch, the first requirement is to study the distribution of pixel values in this range of pixels. Also study the some statistics about the image. For example, minimum, maximum value or maximum value of pixels, what is the mean value and standard deviation. And secondly, when you study this histogram, you would find that it is not just one peak is there, but roughly two peaks are there. It is not in what I am trying to say, it is not in a Gaussian distribution or well shaped. So, for that we must be very careful about making some stretches. I can manually also I can do it stretch, that I say that any value which is found from this should be made to the maximum. If I do it, this is going to be my distribution of my histogram. So, for each channel I can do like this, and I can do manual stretching, or I can do the standard stretching techniques which are available. So, if I am doing this custom one, as you can see, this is a custom one. When I apply whatever I have decided, this is how it looks. So, it is not very good custom one which I have done, and that means you have to keep trying once you are satisfied with that. I made just based on the distribution of the histogram. My selection for the maximum value may not be good. So, I have to work on minimum also. So, I should have taken minimum like this for each band, again here minimum like this, and also for blue. Some changes have occurred, but may not be very good. Whereas, if I choose some already available like histogram minimum maximum is a linear stretch. So, as we have already seen that here the minimum value and maximum value for each band is different. Does not matter if I go for minimum maximum. So, minimum maximum of each band would be stretched to full scale, that is 0 to 255, because each image here is 8-bit image. So, the values can vary between 0 to 55, total number is 256. So, if I go and apply a minimum maximum, then this is what I get. So, minimum maximum again is not good. So, if I go for histogram equalization, it should create maximum contrast and also maybe very good results. As you can see, the results are quite good, but however, it is bringing too much blue color which may not be good. And another one I can try standard deviation. This fits quite well. So, what I am trying to say that for each image there has to be a different image enhancement technique, because the distribution of pixel values is completely different from one image to another. Now, if you mosaic two images, then before mosaicing you should not do any enhancement. Once you have mosaic the images, then for entire mosaic image you should do enhancement, rather than individually first doing on two parts enhancement, and later on if you mosaic them, you may not be able to remove the seam or the line between two images, two adjacent images. So, you have to be very careful about choosing these things. So, what we have seen here that we can create a false color composite. Once we add or load a false color composite, what happens that the red band is assigned to the blue is to red. So, we have to correct it. And secondly, that once if you want to create your own false color composite, you can do it without any problem. Only you keep adding these things, use appropriate tool to create a false color composite. Once you are satisfied with all these details, then or all these enhancements, then you can go and save that image as a separate file. Here, like for example, I go and I say I want to save it. I can provide the name, I can provide the format, and just save it, and it will save wherever you want. So, in that way, next time you do not have to create again a false color composite. False color composite will be displayed as soon as you would add in your view. So, this is about the image handling. One more time you would require image handling when you want to use the images top of your digital elevation model, for which you have to georeference digital elevation model and your satellite image very accurately, and then you can drape over that and can create a 3D perspective view. In ArcGIS, for which you have to use an extension which is called ArcScene, and then using that extension you can create a 3D perspective employing two main data sets, both are raster, one is digital elevation model, another one is satellite image. Both has to be perfectly in same should belong to same geographic coordinate system and should have a very good georeferencing. If that is done, then definitely you can create a 3D perspective view of your study area. Similarly, these 3D perspective view have been created on Google Earth, as you can also see there. So, with this I end this demonstration with a suggestion or request that whichever the software you are using, please download some satellite images from net. There are various sources like if you just type in Google Landsat data download or something, you will get Earth Explorer, very famous portal, or GeoWig, or many other such portals are there, and from where you can get down data, and various portals I have already discussed, or in future also if reference comes we will discuss that part. So, once you have downloaded the data, try on your software to create a false color composite, and also try various enhancement techniques to develop a full and not only theoretical background, but a practical experience too. So, with this, thank you very much.